Hi everyone, my name is Lydia, and together we'll be learning econometrics into the What I Wish They Had Told Me in Econometrics video series. In the last two videos of the introductory bit, we have learned a few things to keep in mind, especially the population model, the types of data you could work with, and how that population model language changes. And today we're going to dive into more jargon and tidbits that most of the times your lecturer is going to take for granted that you know. That might make it a bit more difficult for you to follow through with the lecture, so this is why we're going to go through that today. So without further ado, let's jump into some more jargon. We've seen and talked extensively about the y and the y hat in the previous videos, but the y variable is basically your dependent variable or explained variable, regressant, outcome, whatever is your pick. Keep in mind these are all synonyms and they all refer to your y variable. The y hat is what we call the predicted outcome or predicted dependent variable, the predicted explained variable. Keep in mind the emphasis is on predicted, because the difference between the two, so the y and the y hat, is the y is something that you observe, something that you have in your data, while the y hat is something that basically you are calculating, you are predicting. This is an outcome or result of your estimated beta coefficients and you plugging in certain values of your x variable so that you can get your prediction based on the econometric model that you came up with. The epsilon is what we have called the error term. And I want you to be aware that while the epsilon is mostly used because it's obviously seems like an E, so more easily to be associated with the word error term. In most textbooks, for instance, in the Wooldridge book, you'll see that it's noted as a U. Sometimes you might see it denoted as a V, or any other letter for that matter. The epsilon hat, or U hat, V hat, this is what we will call the residual. And I want to bring your attention that while the epsilon and the epsilon hat might look similar, just like there were very clear differences between your y and y hat, there are very huge differences between the epsilon and the epsilon hat. To begin with, the epsilon is just a theoretical, so to speak, kind of element. It's unobserved. So we know that it's like a collection of all the other variables that are affecting your y variable, but you have not included, be that because you couldn't measure or you just didn't have it available. But it's generally something that it's unobserved and very theoretical. The epsilon hat, on the other hand, now that is something that we can calculate. Now, because these two are so different, you have to be very careful what your exercises ask you, because you not distinguishing between the error term and the residual might mean that you might not be able to ultimately answer a particular question that you're given as homework or in an exam. Okay. One last thing I would like to bring to attention for notation-wise in terms of the error term and the residual, there are some books like the green, and there are certain lecture slides that they might use the convention where E is simply the residual, while the epsilon is kept as the error term. So keep in mind, this is a convention that is very particular. A few lecturers might use it because it's a lot easier, especially on the slides, to use the E rather than the epsilon hat. However, as I said, keep in mind, this would be at the discretion of your lecturer, and you would have signs of it in the lecture slides. So always be careful what the convention is. And I always suggest students go ahead and ask your lecturer. Nobody's gonna frown upon you, especially when it's important elements like this one. The last element that we've been using is the x variable, which we call the independent variable or the regressor variable, and I've put here in capital letters control variable. A lot of students come sometimes very confused about this word control variable. Keep in mind, any x variable is a control variable. Um, it's simply that in most of the published papers, the control variable most of the times is used for a list of variables that you have to include no matter what into your regression. Otherwise, the results that you have cannot be trusted. And that's why you might see in published papers like and other, let's say, demographic control variables. But keep in mind, ultimately, they are simply X variables that are being added into your regression. Okay? So that's why any X variable is a control variable in your regression. More specifically, let's combine all these elements into our specification. So assume we have a y, which depends on x1 and x2. We have beta null, beta 1, beta 2. Remember, these are what we call the coefficients that we need to estimate. And the moment that we estimate means like we have actual numbers, like specific, explicit numbers, and that's why they take the hat. One thing that I would like to bring to attention regarding the coefficients is that they can be any Greek letter, really. They can be alphas, they can be betas, they can be gammas, as long as you have like a Greek letter and an X variable attached to it, you know, this is a coefficient that is going to be estimated. However, if it's a Greek letter that doesn't have anything to it, it can be an error term. So just be aware of that. In some textbooks or in some slides, and again, I say always pay attention to the conventions being used, usually in the first slide show of or slide set in your material. Sometimes you might see the generic formula written as B0 plus B1x1 plus epsilon. And that is also completely fine. You'll be asking, well, it's not a Greek letter, is it? It's also completely fine. Usually the moment that this is estimated, they turn them into Greek letters. It's just simple convention, so don't get flustered by it. In some other textbooks or slide, you might see that y is equal to alpha plus beta x plus epsilon. That is also completely fine. As I said, it doesn't matter what kind of Greek letters you're using for your coefficients. Ultimately, these are still things that you need to estimate, meaning here alpha and the beta. Okay? Now, getting back to our two models, so this is our theoretical model, and this is the estimated model. The difference between what you observe and what you have in your data and what you have predicted, this is your residual. Okay, this is basically the mistake that you're making on your prediction. And this is also the reason why there is no space in here for your epsilon or your epsilon hat. So don't get tempted to add that epsilon hat in the end. Okay, because epsilon hat residual is the difference that you're making between your observed and your predicted values. Before we conclude this video, I would also like to show you one final thing that is also taken for granted that you know. Assume this is your Excel spreadsheet and I've populated a few numbers in here, and it's a cross-sectional, but keep in mind this applies to no matter what kind of data set that you have, be it time series or panel data. What you have to know is that every column is one variable, okay? And every line is an observation. Okay, so every line is an observation, which means that ultimately the number of lines that you have is the number of observations that you are working with, and the number of columns you have is the number of variables that you are working with. I hope this clarifies now a few of the things or a few of the words that maybe were a bit not clear during your material review. And thank you for following the introductory bit, and I'll see you in the next videos.